everyone. Welcome to our exploration of adding, subtracting, multiplying, and dividing algebraic fractions. Before we begin, I would just like you to take a moment to practice your calculations with normal fractions that don't involve algebra. So please can you pause and try these questions, and then we will go through the solutions together, as well as some useful reminders before we delve into the algebraic fractions. So please pause now. Okay, guys, well done. Let's take a look, see how you did, and also at the same time, I will give you a few hints and useful techniques to make your life easier when we deal with the algebraic fractions, okay? Right, so here we go. Let's just focus so you can see really well. Lovely. Okay, so let's first look at question 1a. We had 5/12 plus 7/18. Now we needed to make sure that our denominator was the same. If we look at 12 and 18 and we look at their multiples, 12, 24, 36 for the 12s, and 18 and 36, and so on for the 18s, then what we find is that the lowest common multiple is 36. So I want to make sure that my denominator is 36. So we think about how we do that. Well, to turn a 12 into a 36, we multiply by 3. So I have to make sure to multiply the denominator by 3 and the numerator by 3 so that we don't change the value, and that will give us our 36. And similarly, to turn an 18 into 36, I multiply by 2. So we multiply the numerator and the denominator by 2. Now that gives us 15 over 36 plus 14 over 36, which is equal to 29 over 36. I know I'm finished because 29 is a prime number, so I can't cancel that down. There isn't another set of 29s in 36. It doesn't fit perfectly, so there's no canceling down to be had. Okay, so that's finished. Right, if we look at part B, very similar type of question. In this case, our common denominator would be 99, okay, or our lowest common multiple. So 11 times 9, 7 times 9, 9 times 11, and 2 times 11 will give us the 99s in the denominator. 63 over 99 plus 22 over 99 gives us 85 over 99. Again, there isn't a common factor, so we didn't have to simplify. Right. Let's look at this example. So I've done it this way, and then I've reflected. So let's take a look. I thought 12 and 5, definitely 60. Very good. So we did 9 times 5, 12 times 5, 4 times 12, and 5 times 12. And that gave me 45 over 60 minus 48 over 60, which gave me negative 3 over 60. At this point, I realized that 3 goes into both, and we get negative 1 over 20. Well, whenever this happens, there is a chance I could have simplified earlier, okay? And if I look back at the beginning, I definitely could have simplified this particular fraction here. 9 over 12, the 9 and the 12 divide by 3. Right away, I could have made that, if I divided by 3, 3/4. Okay, and that would have made my life a bit easier. That would have meant that actually my common denominator was 20 straight away, and I wouldn't have had to simplify at the end. It's easier to simplify earlier when you have simpler fractions. Okay, moving on to question 2, where we were multiplying and dividing. Okay, multiplication is fairly straightforward. Okay, we are literally multiplying the top, getting that product, multiplying the bottom, getting that product, and that gives us our answer. So 5 times 2 over 7 times 11, which is 10 over 77, and there we go. Can't simplify that either. Right, we move to part B, where we now divide. Now at the beginning, you needed to remember keep, change, flip. Okay, so 6 over 7 we keep, we change this to a multiplication sign, and we flip the second fraction. So that's 9 over 5. Okay, there isn't anything I can cancel down here. So 6 times 9 is 54 over 7 times 5, which is 35. And that gives me 1 and 19/35. Okay, so that's finished. Can't do anything else. However, I've not finished this one on purpose so that we can talk about it. We have 25 over 32 divided by 35 over 14. First things first, no canceling until I have changed this to multiplication. So 25 over 32 times 14 over 35. Now I can start to think about how I could cancel this down. Now 25 and 35 are both multiples of 5. So that's what I'm going to do. I'm going to divide both of those by 5. 25 divided by 5 is 5, and 35 divided by 5 is 7. But I can now go further. If we look, 7 goes into 14 perfectly. So actually, this 7 can become a 1, and this 14 can become a 2. And actually, I can go one step further. Those are going to make it so I basically have to do very little work when it comes to multiplying. Okay, this 2 and 32 are both multiples of 2. So my 2 can become a 1, and this can cancel down to a 16 when I divide it by 2. Well, funny enough, 5 over 16 times 1 over 1 is just 5 over 16. So what I've done is I've simplified earlier, I canceled down, making getting to my final answer much, much easier. Okay, so that's kind of my little trick. It's not really a trick, it's just being smart about the maths. Okay, all right, so what I would like you now to do is pay attention as we go through a specific example together of how we're going to use these techniques. Right, so in this example, it says to write things as a single fraction in the simplest form. Now, part A, they've started out for you. They've got x over 2 times x over 3 is equal to x times x over 2 times 3. That is true. You don't need to write this step. I'm going to put a bracket around it, okay, if you don't want to. If you can see right away that x times x is x squared, and that 2 times 3 is 6, then you're done. So this is optional. This is only there if you need it so that it can help you if you need it, okay? But don't feel like you have to do that step. Right, so for part B, we have 2x over 5 times 3y over 4. Okay, so let's take a look. 2x times 3y, I suggest always that you do the numbers first and then worry about the letters. 2 times 3 is equal to 6. X times y is xy, so my numerator is 6xy. And 5 times 4 is equal to 20. Now, I can cancel down. In this case, I could have over here, but I forgot, so we're going to do it here. All right, and we divide by 2, and that gives us 3xy over 10, dividing the top and the bottom by 2. Okay, right, and finally for part C, we have 4 over 9y times 3 over 5y. Okay, can I cancel this at all? Let's see if we can. Absolutely. 3 and 9 go into each other, so that would be a 1 and a 3y now. So that's 4 times 1, which is 4, and 3y times 5y is 15y squared. Okay, and that's finished. You need to be confident and comfortable with multiplying your letters together and, of course, your numbers to be able to do this. And you also need to take a moment to pause and say, can I cancel this down? That's particularly important when we have larger numbers. Smaller numbers like this, you can probably cope with either way. Once we get to larger numbers, you really want to cancel down as early as possible to make it easier when you get to the end of the question. Right. So I'm going to make this a bit bigger, okay, so that you guys can pause the video and try them. All right, but literally where you can cancel, please do. There's a hint for question 5A and B, and also question 4A has been started for you already. Okay, so pause the video, off you go, and then we will go through the answers together. Okay, guys, well done. Thanks for doing that. Let's take a look. There we go. Okay, so if we're looking at question 4A, you'll notice that they've already started the question off for you. It's very nice. That's not going to happen in an exam. Okay, it only happens in your book. And what we really want now is to cancel down letters and numbers. Okay, so I can see that a 4 goes into an 8 twice. So that becomes a 1, that becomes a 2. I can also see that x goes into x squared. So that just becomes a 1. Technically, 2 times 1 is 2, so I'm not going to write that down. And instead of having x squared, I now just have an x. If we now look here, 3, no, it's not going to help us, but the y's do cancel down. That will become a 1, so we don't need to really write anything there. Okay, and then instead of y cubed, I will now have y squared. Okay, so when we multiply across, that's going to give me 1x times 3, which is 3x all over y squared times 2, but we write the number first, so 2y squared, and that's correct. Okay, so well done those of you who got that. Part B, 14x cubed over 10y squared times 25y to the 6 over 21x to the 5. Okay, so let's first see if we can cancel anything down. Always start with numbers. It's much easier. Okay, and I'm going to say first let's divide these by 2. So we get a 5 and we get a 7. Now we're going to see anywhere else we can cancel. Absolutely. 5 goes into 25 5 times. That goes away, becomes a 1, and that becomes a 5. Okay. 7 goes into 21 3 times, so let's make that a 1, and let's make that a 3. So now I've done the numbers. I'm happy with that. Is there anything we can do with the letters? Well, y squared, 2 of the y's will cancel out, and that will give me y to the 4. I'm going to rewrite that out so it's a bit nicer. Okay, and x cubed and x to the 5, well actually these are the ones that cancel out, leaving me with x squared. All right, so my final answer here is going to be, there's only one left here. 1 times 5y to the 4 is 5y to the 4, all over, we've only got a 1 left here, times 3x squared, which is 3x squared. Much easier to cancel down earlier. Okay, I'm hoping you're getting that concept now. Let's try part C. We have 12y squared over 7x times 14x to the 5 over 16y to the 4. Okay, lovely. Let's take a look. Let's start with the letters. Let's start with the numbers. 7 goes into 14 twice, so let's make that a 1 and that a 2. Okay. I can cancel down a bit more here. Let's just work on this fraction. So 2 goes into 16 8 times, so let's make that a 1 and an 8. We have 12 and 8 both dividing by 4, so we're going to make that 2, and we're going to make that 3. I've done the numbers. I now need to look at the letters. X goes into x to the 5, making that x to the 4. Okay, and y squared goes into here, and that will make that y squared. All right, we've done our canceling. Let's take a look at our answer. We have 3 here times 1x to the 4. So that would be 3x to the 4 all over this one where we just have 1 left over, and then 2y squared. So that becomes 2y squared. Right, so really important that when you do this, you keep track really well. You know exactly what you've done so that you don't forget a number, okay, or a letter when you get to this stage. All right, but that's completely finished. Okay, so question 5 was the one that gave you some hints, so let's see how you did. Okay, so they want you to write it as a single fraction. This time we have division. So we've got 4 over x divided by 3 over x. Okay, so their hint was dividing by 3 over x is equivalent to multiplying by x over 3. We already know that based on keep, change, flip, okay, which you guys have learned. So let's change this to 4 over x times x over 3. And what's really nice about this is those cancel out and become 1s, and we are left with 4/3, which you can write as 1 and 1/3. Okay, well done. For part B, we have x cubed y divided by 1 over xy. Well, anything can be written over 1. Okay, and that was the hint they gave you, and that's useful because now it looks like a fraction. So that's going to give us x cubed y over 1 times xy over 1. Okay, which means actually we're going to end up with 1 in the denominator, so don't really have to worry about that because when we divide by 1, you get itself. But what we actually need to do is finish multiplying here. X cubed times x will become x to the 4. Okay, and y times y is y squared, giving us our final answer of x to the 4y squared. Okay, and part C, we had 2y cubed over 3x to the 5 divided by 8y7 over 15x cubed. We need to change that to multiplication, so that is 2y cubed over 3x to the 5 times 15x cubed over 8y to the 7. Now I can start to cancel down and simplify. So if we look, 2 goes into 8 4 times, so we change those. 3 goes into 15 5 times. That's our numbers sorted. Now we look at the letters. Y to the 3 goes into y to the 7, leaving us with y to the 4. And x to the 3 goes into x to the 5, leaving us with x squared. So what do we end up with? We only have one left here. 1 times 5 is 5. Okay, and 1x squared times 4y to the 4 is going to be 4x squared y to the 4. And that is our final answer for that question. And finally, in part D, we had y over 2 divided by y minus 7 over 10. Okay, keep change flip. So we have y over 2 times 10 over y minus 7. Now, this is a really important one to focus on. You cannot cancel these y's. And the reason for that is this isn't multiplicative. This is y minus 7. That's two separate expressions brought together. Okay, so you cannot cancel that down. But I can cancel that 2 and the 10 by dividing by 2. And that is going to give me my final answer of 5y over y minus 7. And there we go. Okay, so that's that section sorted. And hopefully you guys do really well there. All right, which brings me to the next thing we need to master. Okay, and that is, how do we add and subtract algebraic fractions? Well, I'll be honest with you, it's exactly the same as adding and subtracting when we have normal fractions. We need to make sure the denominator is the same. Okay, so that's the key thing, same denominator. And if we can do that, then we can add and subtract these fractions. Okay, so the example here we have on the left is x over 5 plus x over 3. Okay, and if we had numbers on the top, we would know that we would need 15 on the bottom or in the denominator, because that is the lowest common multiple of 5 and 3. And that's exactly what we're going to do here. Okay, so times 3 times 3 times 5 times 5. And that would give us 3x over 15 plus 5x over 15. And we know that when we add x's together, we add their coefficients. And so we get 8x over 15. And that is the answer to that question. Okay, I'm going to do one more with you just so that you're ready for the questions coming up. Okay, and this example, you might want to pause and write it down. Okay, is going to be 1 over 2x plus 3 over 3x. Okay? Right. Now, remember, we said we could always cancel things down if possible. And a 3 and a 3 do cancel down, so let's do that. They both become 1s. So actually, the question I'm answering is now 1 over 2x plus 1 over x. Now, I need to make those denominators the same. Well, 2x and an x, the only thing I need to do is multiply this by 2 and this by 1. Do we need to show times 1? No, we don't really, because we know it'll be itself, but I should really show my work here. Okay, and that is going to give me 1 over 2x plus 2 over 2x, which gives me 3 over 2x. Okay, and that would be my final answer there. So the same principles apply when we have letters in our denominator. We need to make sure that the denominator is the same before we can add or subtract the fractions. With that in mind, please, as I make this full screen, can you pause the video and try those questions? We'll go through the answers momentarily. Okay, thank you for doing those. There we go. Lovely. Right, so when we look at question 6, part A, we had 3x over 10 plus x over 2. My common denominator is going to be 10, okay? So let's just multiply this side by 5, and that is going to give me 3x over 10 plus 5x over 10, which will give me a final answer of 8x over 10. Okay, then I ask, can I simplify that? Absolutely, we can simplify that, divide by 2, and that is going to give me 4x over 5. Final answer. Well done to those of you who got that one. Part B, 4x over 3 minus x over 4. Okay, so in this case, we'd like 12 to be our common denominator. So we're going to multiply by 4 and then by 3. Okay, that is going to give us 16x over 12 minus 3x over 12, which will give us 13x over 12. Now, you might be wondering, well, can't I just divide out the 12? Well, no, we don't want to do that because this doesn't say 12x. Okay, so we can leave that as our final answer. There's no need to make a mixed number there. You can't. Right, so for part C, we have 6x over 7 minus x over 2. We would like 14, so we multiply by 2, and then we multiply by 7. And that will give us 12x over 14 minus 7x over 14, which will give us 5x over 14. Final answer. I can't cancel anything down. Right. Okay, so for question 7, it was fairly straightforward. You needed to find the lowest common multiples. They gave you a hint. List the multiples as if you would normal multiples. So multiples of 2 are 2, 4, 6, 8. So multiples of 2x would be 2x, 4x, 6x, 8x, etc. Okay, so if we look at question 7a, my lowest common multiple for a 2x and a 5x would be equal to 10x. Okay, if we look at part B, my lowest common multiple for a 3x and a 6x is equal to 6x because 3 goes into 6. For part C, when I have 4x and 7x, okay, my lowest common multiple there is going to be 28x. Okay, and my very last one, part D, where I had a 4x and a 3x, my lowest common multiple is 12x. Okay, so hopefully those made sense. Okay, very similar as if we were just dealing with normal fractions. The only difference now is we have an x attached to our number that's multiplied by it. Okay, lovely. All right, so that brings us to your next task. So once this is full screen, can you please pause the screen now and try these questions? Pause the video. Okay, guys, welcome back. Let's take a look to see how you did and see if we can help you out at all. Okay, right, so for question 8a, they want us to write 1 over 4x and 1 over 3x as equivalent fractions with the denominator, the LCM of 4x and 3x. Okay, in other words, a little bit of a complicated way of saying, can you turn them into a fraction with the same denominator? Okay, and then add them together in part A. So if we were to look, in part B. So let's take a look. So we've got 1 over 4x, okay, and we've got 1 over 3x. Well, our lowest common multiple will actually be 12x. So in order to turn this into 12x, I need to multiply by 3. So my equivalent fraction there is going to be 3 over 12x, okay? And here, I would need to multiply by 4. And my equivalent fraction will be 4 over 12x. Now, you might be thinking I can cancel those down, but you're not going to do that because we're about to add them together. So in part B, we end up with 3 over 12x plus the 4 over 12x, which would give us a final answer of 7 over 12x. Okay, so hopefully you guys were okay with that one. Well done. Now let's look at question 9. It says, write as a single fraction in its simplest form. So in other words, find your common denominator and add or subtract. So let's do that. So we have 1 over 9x plus 1 over 2x. Our common denominator is going to be 18x. So we multiply that by 2, and we multiply this one by 9. That will give us 2 over 18x plus 9 over 18x, which gives us a final answer of 11 over 18x. Okay, so well done. And that was part A. If we now look at part B, we have 1 over 4x minus 1 over 5x. Our common denominator is going to be 20x. So we multiply by 5 and by 4 for the second fraction, and that will give us 5 over 20x minus 4 over 20x, okay? And 5 minus 4 is 1, so we end up with 1 over 20x, final answer. Okay, let's look at the last one for question 9. So part C is 1 over 6x plus 5 over 9x. All right, there's a little bit more thinking involved with this one. We don't want to go too high. I mean, it could go to 54x, but I'm going to have to cancel down the lowest common multiple. If I took a look at their multiples, 6, 12, 18, 9, and 18. Okay, so actually I would rather use 18. It's smaller. So we're going to multiply that by 3, and this one by 2. And that will give us 3 over 18x plus 10 over 18x, which gives us our final answer of 13 over 18x. Okay, so really well done on that. Right. Now in question 10, they helped you out and they asked you to copy and complete. Okay, for some of us that actually can be more confusing, but hopefully we were okay. So they gave us x minus 4 over 2 is equal to something times x minus 4 over 5 times 2. Well, if we remember that we have to do the same to the numerator as the denominator, or vice versa, then that number is going to have to be a 5. Okay? So your first answer there should have been a 5. Right. We then can go one step further, so they've expanded. So 5 times x is 5x. 5 times 4 minus 20 all over 10. Okay, and that should have been your answer to part A. Let's take a look at part B. We had x plus 7 over 5, and this time they're multiplying by 2, so we want 2 brackets x plus 7, so that was your answer for that box. All over, they said 2 times 5. When we expand, that's going to give us 2x plus 14 all over 10. Okay? Then it says use your answers to part A and B to work that out. Well, we've already made the denominators the same, so let's use our new versions to add them together. That would be, for part C, 5x minus 20 over 10. We're adding, so plus 2x plus 14 all over 10. So let's bring the numerators together. So that is going to be 5x minus 20 plus 2x plus 14. And here's where the ruler comes out, because that's a long line. All over 10. Okay. And 5x plus 2x is 7x. Negative 20 plus 14 is minus 6. And that is all over 10. Okay, and now that's finished. We've added them together. All right, so well done on those guys. Really proud. Okay, let's move on to our next set of questions. Okay, so we've practiced that with that example. I'd now like you to press pause and try these, and then we will go through the solutions together. Okay, well done on that. Let's take a look. Okay, right, so here for question 11a, we had x plus 2 all over 2 plus x plus 1 all over 3. Okay, so we want our denominator to be 6, so we are going to multiply by 3 and by 2. Okay, how will this look though? Well, we know we're going to get 6 in the denominator, but we're going to have to use a bracket and then expand. So for this first one, it's 3 times the x plus 2, and there's a plus sign, and then 2 times the x plus 1, all over 6. Okay, and now we can expand. So that's 3x plus 6 for our first bracket, plus 2x plus 2 for our second bracket, all over 6. Okay, and finally, 3x plus 2x is 5x, 6 plus 2 is 8, and that is all over 6. And so that one is complete. All right, guys, so the process is the same. It's just now we have to expand brackets. Okay, so for part B, let's take a look. We have x plus 5 over 2 minus x minus 3 over 7. Okay, it's really important that we keep track of our brackets and don't try and do this all in one step, okay? And that's particularly when we've got a negative. That's important. So we're multiplying by 7 and we're multiplying by 2, okay? So we've got 7 brackets x plus 5 minus 2 brackets x minus 3. So notice that that sign is what was here. Okay, and that is all going to be over 14 because 2 times 7 is 14. Now this is why you have to write it like this, because if I was just to do negative 2 times the x, I might forget that I'm actually doing negative 2 times the negative 3 as well. So let's expand. We have 7 times x, which is 7x, and 7 times 5 is 35, okay? Negative 2 times x is minus 2x, and negative 2 times negative 3 is plus 6. And that is all over the 14, which now means we can simplify and finish, okay? 7x minus 2x is 5x, and 35 plus 6, okay, is 41. So plus 41, and that is all over our 14, and we are done. Okay, so well done those of you who got that one. Excellent. All right, so let's take a look at part C. We have x plus 7 over 4 minus 2x minus 1 over 9. Okay, 36 is what we're looking for. So times 4 over here and times 9 on our first fraction. And that is going to give us 9 brackets x plus 7 minus 4 brackets 2x minus 1 all over 36. Okay. Now at this stage, we're going to expand 9x plus 63 minus 8x plus 4. Okay. All over 36. And now we can simplify. 9x take away 8x is 1x. We don't need to write the 1. And 63 plus 4 is 67, and that is all over 36. Okay, lovely. Well done. All right, so question 12 is an exam question. It's very similar to question 11. If you found question 11 difficult, can you now pause, okay, and try question 12 yourselves, and then I'll go through the answer, okay? If you found it fine, then we'll just go through the answer right now. But if you did find it difficult, can you please press pause and try question 12? Okay, so for those of you who tried that again, well done. Let's go through the answer together. Okay, so we have x plus 6 all over 2 plus 2x minus 3 over 5. Okay, we need to have 10 as our denominator. And so we get 5 brackets x plus 6 plus 2 brackets 2x minus 3 all over 10. Okay, we expand, we get 5x plus 30 plus 4x minus 6 all over 10. And our final answer, 5x plus 4x is 9x, and 30 minus 6 is 24, and that is, as we know, over 10. Okay, so really proud of you guys for getting that. All right, we're going to stop there for today's lesson. I thought you did very well, and I look forward to the next one, okay? We're going to start it off with a few more applications of this, but I think for today that is enough. You did really, really well.